Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at logarithmic scales. Now they come up in many different areas, such as looking at strength of an earthquake, in pH in chemistry, the brightness of something. The example I will go through is that of sound. We measure sound in decibels, and the number of decibels of a sound is calculated according to this formula. D is the number of decibels. It's 10 log base 10 of I over I0. So here I stands for intensity. I0 is like the zero intensity. It is the softest sound the average human can hear. Turns out to be energy of about 10 to the minus 12 watts per meter squared. So in terms of intensity, we really mean the energy. Now this is what's known as a comparative formula. The number of decibels of a sound is determined by, is it twice as loud as the softest sound a human can hear? Is it 100 times as loud as the softest sound the human can hear? And here, when I say as loud, we mean intense, which is the amount of energy that it releases. Now, logarithmic scales have a useful benefit that it stops us needing to work with really, really large or really, really small numbers. I mean, 10 to the minus 12 is a very, very small number. So this formula basically converts it into a number that's actually useful. Okay, so what about if a sound gave off energy of 10 to the minus 6 watts per meter squared? What would be its decibel rating? What would be the number of decibels? Well, we simply substitute this into the formula. So we would have number of decibels equals 10 log base 10. So here I substitute for 10 to the minus 6, and I0 is 10 to the minus 12. So 10 to the minus 6 divided by 10 to the minus 12 using index laws actually equals 10 to the positive 6. Negative 6 subtract negative 12. So log 10 of 10 to the power of 6. What do you raise 10 to get 10 to the power of 6? Well, you raise it to the power of 6. So that would be D equals 10 times 6, which is 60. So a sound that emits this energy would be 60 decibels. All right, let's now look at comparing two different sounds using this scale. So if one sound is 20 times as intense as another, what would be the difference in decibels? So I'm going to let D1 be the decibels of the louder sound and D2 the decibels of the softer sound. So D1 I'm going to write as 10 log 10. I'm going to call it I1, the intensity of the first sound, over I0. And then for D2, its decibels will be 10 log base 10. I'm going to call it I2, intensity of the second sound. Okay, it turns out we can simplify this formula quite a bit. So firstly, we can take out a common factor of 10. And we're left with log base 10 of this minus log base 10 of this. So using log laws, we can make this even simpler. So what we have is 10 outside of, we combine this into a single log. Now what will happen, it will be I1 divided by I0, but then it's going to be divided by I2 over I0. Now, when you're working with these, we can actually just cancel out the I0s. It's 10 log base 10 of I1 over I2. Now, if one sound is 20 times as intense as the other, so if sound 1 is 20 times intense, it gives off 20 times as much energy, I1 over I2 is going to be 20. So the difference in decibels is simply going to be 10 log base 10 of 20. And you can put that on your calculator, you get around about 13. So the louder sound is going to be 13 decibels larger. So every time you go up by 13 decibels, the sound is getting 20 times as intense. It's releasing 20 times as much energy. All right, to understand the formula a bit better, we're now going to rearrange this and make I the subject of the equation. So how do we do that? Well, first thing we need to do is divide by 10. We get D over 10 equals the log. So now we want to undo log base 10, and we undo that by taking 10 to the power of. So if I take 10 to the power of both sides, 10 to the power of log 10 undoes each other. I'm just left with I over I0. And then finally, I just go 10 to the D over 10 times I0. Well, I0 was actually 10 to the minus 12 watts. So this will give us a formula for the intensity, and of course we can convert that using index laws into one index. So the intensity is 10 to the power of the number of decibels divide 10 minus 12. So if we know, for example, that a sound is 120 decibels, which is super, super loud, we can easily find its intensity. It would just be 10 to the power of D is 120 over 10 minus 12. Actually gives you 10 to the power of 0, which is 1, and intensity is watts per meter squared. That's how much energy would be exerted by a sound that's 120 decibels, which is really bloody loud. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.